Hi, welcome to this channel. Today we will solve Leetcode 1642, which is furthest building you can reach. So in this problem, we have given an array of a height of building. So this array represents the height of a building and number of bricks and number of ladders. So what we need to do is we have to use these bricks and ladder and need to return at what place we can reach if we start from the index 0. So we need to return the farthest index we can reach. How we can use these bricks and ladder is if there is increase in height, right, from 2 to 7 there is increase in height, so we can either use a ladder or number of bricks, which is the difference of these two heights. And yeah, we need to return the farthest index we can reach. So for this example, let me just see. So here for the given example 4, 2, 7, 6, 9, 14 and 12, I am writing the difference whenever there is increase in height. So from 2 to 7 there is a difference of 5, here it is 3, here it is 5. And number of bricks given is 5, ladder is 1. So in this case, at the first place, let's say we use bricks over here because we can use, and here now the brick number of bricks would be 0. Again here the difference is 3, we don't have any bricks, we need to use ladder now. So we can reach till index 4. After that this gap we can't fill because now we have 0 ladder and 0 bricks. So we will be able to reach at index 4. So for this case the answer would be 4. So as per the question you can see that we have uh, three options only. Either we don't use anything. For here 4 to 2 it's a decrease in height, so we don't use anything, and some places we can use bricks and some places we can use ladder. So we have to use bricks and ladder in such a way that so that we can reach as farthest as possible. So one simple solution would be we have three options for each gap, so we can try all of them and see which one gives us the better result. So brute force approach would be we have n minus 1 gaps. For each gap we have three possibilities: either we don't use anything, or we use bricks, or we use ladder. So this will be the time complexity in this case. Let's think about some optimization. So in this approach, if you see that we have three options, but when there is an increase in height we have only two options: bricks and ladder. So if you think of dynamic programming here, because it's a recursive solution, we can either use bricks, either use ladder. So if we try to write the function, let's say function signature would be something like you have to provide the starting index from where you have to start, and the number of bricks you have and number of ladder you have. So what this function will do is it will start from index 0 and use these many bricks and ladder, and you have to return what is the farthest index you can reach. So this will be the instance, and if you try to implement it, if you directly implement it, it becomes the exponential solution, which is O of 3 power n minus 1. But if you try to save something, then it becomes these are the inputs, right? So it becomes the three-dimensional dp. So that if you want to just save over here, so it looks like something solution like this. But as you can see, the size of L in the order 10 power 5, so definitely we are not able to solve in O of n cube dp. So let's think about some other solution. Before going to here, I wanted to point it out two things. So as you can see, if you directly implement with the help of DP, it's going to take a lot of time. So if you think some greedy solutions here, what are the possibilities? And whenever we are providing greedy solution for any question, we have to give some kind of proof whether it's working or not. So I'll just quickly take few thoughts here and see if it works or not. So in greedy solution, if it works, we have to prove it, and if it doesn't work, we have to give some example where it doesn't work. So one simple thought will come here is we can use bricks first and then we use ladder. So let's see whether this works or not. So in order to prove that whether brick first and ladder will work, I'll take one example, and if it doesn't work for that, it means that it will not work. So let's say I'm not writing complete array, I'll write the gap only. Let's say we have 3 gaps. First one is of 9, next one is of 2, next one is 5. And number of bricks we have, let's say 10, and number of ladder we can take 1. So in this case, what happened? If you use brick first, so here we will be using bricks, and then now our bricks count will become 1 now. Now here we can't use bricks, we have to use ladder. So if you follow this way, we will be able to reach to this index. Now, but the better solution would be if you use ladder here, and we can use bricks here as well as here, because total sum over 5 plus 2 will be 7, which we can use. So this way we will be able to reach over here, which is the better solution. So obviously this will be wrong. Second thought will be the opposite of this. You might think of firstly let's use ladder and then we'll try for bricks. So here also to prove this, you can take simple example. Let's say we have 3 gaps, and I'll take same number of bricks again. Bricks would be 10 and number of ladder would be 1. And the gap we can take is, let's say 1, 2 and 9. So if you use ladder first, so here we'll use ladder, and then ladder count will be 0. Now we have to use bricks only, so here we can use bricks. Now bricks will be 8, and now we have 9 but we can't use bricks, so this way we will be able to reach here. But the better solution would be if you use bricks here and bricks here. If you use bricks here and bricks here and ladder here, so in this way we will be able to reach, which is the better solution. So somehow prioritizing one over other won't work here. Okay, then what we can think of, see the ladder, and what is the difference between these two? Whenever we are going to use bricks, we have some number, and then based on that we'll see whether that number can satisfy the gap or not. But ladder, there is no condition. Even if we have an infinite amount of gap, we can use it. So we have to use ladder on the places where we can't use the bricks. And in the question, we have to optimize the number of gaps we can fill, the maximum number of gaps we can fill. So the simple thought process over here is, if we have some number, let's say 10, and we have to distribute this, let's say some items, we have to distribute with the many number people, as many people as we can. So what we can do is, and each person will have some requirements, like they have the fixed things, like they either take a number, let's say there is a person, he can take 2 numbers over here, this person take 5, this person take 6 or something like that. So these are the gaps. So with this number, how we can fill is, we wanted to fill as many gaps as we can, right? So there is, let's say 9. So we have to, if you want to increase the numbers, the only way is we have to start filling the minimum gaps. So if we start from here, we will be able to fill these 2 gaps. but let's say if you start from here, we will be able to fill only one gaps. So this is the basic idea. So what we can do is, for the larger gaps, we will try to use ladder, and for the smaller gaps, we will use bricks. So how the algorithm works is, we have fixed number of ladders. So we will traverse the array. Let's take the same example: 4, 2, 7, 6, 9, 14, and 12. And the gaps are 5, 3, and 4. So here the gaps is 5, 3, and 12. Okay, so algorithm here is, what we can do is we can create a max heap, and in this max heap, what we will try, whenever we find a gap, we add into the max heap, as well as we decrement this number of bricks. So, and at any point of time, if bricks is exhausted, then we will place the ladder at the maximum gap that we have. For example, let's say we have gaps something like this. I'll give a number, let's say 2, 5, 7, and 3. Which are the gaps we have. Then at this point, if my bricks exhausted, then I have to place the ladder. So where I can place ladder is the maximum gap we have. So here I will place ladder, and this number will again be added to the number of bricks we have. So bricks will be 7. Okay. So in this way, what we are doing is effectively we are trying to use ladder where to the maximum gaps, and the remaining smaller gaps are being filled by the bricks. So ladder will be used for the maximum gaps. So if we have total ladder equal to 3, so top 3 gaps will be filled by the ladder, and the remaining gaps will be filled by bricks. Okay. And let's think about the what is the time complexity and the space complexity here. So the time complexity here, what we are doing is we are creating a max heap, and we are adding each gap over here, and whenever the bricks number of bricks exhausted, then we remove the element and update the gap. So for each index, we are adding some element into the max heap, so which takes log n time, and total we have an element. So time complexity would be O of n log n. And space complexity, we are using max heap, which can go in first case of O of n. So space complexity would be O of n. Let's see the solution. So what I did here is I start with the index 1 and then see what is the difference, and then if difference is less than 0, we need not to use either ladder or bricks. And then what I'm doing is I'll add this current if, considering this as the maximum. I'll add it, and I will also decrease the bricks, number of bricks. Then if number of bricks is less than 0, it means that now bricks is exhausted. Now I have to replace the highest gap by the ladder. So we'll see whether we have some ladder or not. If we don't have a ladder and we don't have a bricks, we have to stop it. Otherwise, what we need to do is we have to decrease the ladder. It means that at the maximum gap, I'm using the ladder. So that much bricks that we already used will be again come back to the, so bricks will be incremented and ladder will be decremented. And finally, if in between there is no such problems happen, then we will be able to reach to the students. Okay. Thanks for watching. If there is any doubt or suggestion, please write into the comment section.